And so this is an example of Newton's second law incorporating motion vertically. It's question 10 from your worksheet. Reads an elevator that has a weight of 3,000 newtons is accelerated upwards at 1.5 meters per second squared. What force does the cable apply to give this acceleration? One thing to remember with Newton's second law, write that down here, the net force or the average force is not necessarily the applied force. The net force is a sum of all the forces. If there's only one force acting on the object, then that is the net force. But in this case, this object's being pulled upward through a rope, but at the same time, it's easy to forget that gravity is pulling downward. So there's two forces in play. So another equation we have to consider is that the net force is equal to the sum of all the other forces. This is the force of gravity and the applied force. We're trying to find the applied force. Okay, so the only equation with the applied force in it is the sum of all forces, this one. So I need force of gravity, which I'm given in the question. That's weight, that's 3,000 newtons. What I don't have is the actual net force on the elevator. So that's what I need to figure out right now by using Newton's second law. Okay. So before I get started with the math, reminder of my coordinate system. Up is positive, down is negative. And now I need to figure out the net force. Okay. So the net force is the mass times acceleration, but I'm missing the mass. Do not put 3,000 there. That is not the mass. 3,000 is the weight. Okay. So the force of gravity on this thing is 3,000 newtons. Remember, that is the mass times the acceleration due to gravity. So 3,000 newtons, object's weight, equals the mass, which we're trying to figure out, times 9.81. So dividing both sides, we get 306, just round it up to that, kilograms as the mass. So the mass of this object is 3,006 kilograms. So now I can figure out the net force. Net force equals the mass times the acceleration. So the net force is 306 kilograms times an acceleration of 1.5 meters per second squared. That gives you about 459 newtons as our net force. Now remember, did I take into account direction correctly? My answer is positive. The elevator is going up. Up is positive, so I'm good. I'm okay there. So now I go to the sum of all forces relationship for net force. So I'll write that down again down here. Net force is going to be my force of gravity added to my applied force. My net force is 459. Force of gravity, negative 3,000 newtons. Very easy to forget that negative here. When I solved for my mass earlier, I did not put my negative 3,000 in. I was just considering the force of gravity as a whole, but if you want to, by all means, you can put a negative in front of the 3,000 newtons because it's directed downward, and then you can put a negative in front of the acceleration due to gravity because it is also directed downward. The division will still give you a positive mass. And back to our net force equation, 459 newtons equals negative 3,000 newtons plus my applied force. So adding 3,000 to both sides, giving us an answer of about 3,460 newtons as our applied force. It's positive, which means it's directed upwards, so that at least conceptually makes sense. It also makes sense that it's larger than the force of gravity. In order to move an object up, you have to lift with more force than its weight.